There aren't really notes today. In fact, there aren't notes today. There's no really or caveats about it. There's no notes today. All we're going to do is work some of worksheet 7 together. Exponent equations was Friday. Log equations was yesterday. And so today is just like, all right, let's pause. Let's make sure we can really do these. So nothing new today. Let's just practice what we did Friday and Monday. Let's also scramble them up a little bit, because Friday was all exponents, yesterday was all logs. So now let's shuffle them up and make sure we can still handle things. But basically, if there's an exponent equation, you log both sides. If there's a log equation, you turn it into an exponent equation. So again, logs and exponents go together like squares and square roots. They cancel each other out. Just like if there's an x squared in a problem, eventually you might square root it. If there's a square root, you eventually square it. If there's an exponent, you log it. If there's a log, you exponent it. All right, number 1. So that's an exponent equation, but it doesn't really matter if you know what it's called. It's far more important you know what to do. Do you know what you would do first on number 1?
Multiply by e to the power.
Good. Multiply both sides by e to the x. That way your denominator's not there anymore. So e to the x plus 1 equals 2 e to the x. What do you want to do next?
Subtract
I wouldn't subtract the 1.
Subtract e.
I would subtract e to the x to get them all on one side. And then here's a really fun Algebra 1 mistake to make. 2 e to the x minus e to the x, so you're like, Algebra 1 students think you're subtracting off the e to the x and that equals 2. No, that's not right, but if you're not paying attention, maybe. I have 2 of these things and I'm taking away one of them, so I have one of them left. So e to the x equals 1. I guess officially we're supposed to natural log both sides, but that's one where you could look at and think, wait a minute, I know the answer to that. E to what power would give me 1? 0. Now, the official way would be natural log both sides. So we'll keep going and see what happens. We natural log both sides so that x can come down front. But there we are, natural log of 1 is 0. Why don't you try number 2? So go back and forth a little bit.
I don't understand why natural log e just disappears.
Okay, so you move that down front, and you have x times natural log of e. The natural log of e means that e to some power is equal to e. Well, e to what power would give me e? E to the first power would give me e. So the natural log of e, it's not that it disappears, it's that it equals 1, and x times 1 is just x. It backs up, you just have to know some of these rules, preferably rather quickly rather than having to think through them. The natural log of e is 1, the natural log of 1 is 0. You need to know those probably rather quickly rather than having to figure them out every time. I mean, you can figure them out if you need to, but it would just be helpful if you just knew them. All right, I'm going to press pause on the video. Why don't you try number 2? Really similar to number 1, but a little bit different. So let's see. So we multiply both sides by e to the x. If but I can't really add them. They're not like terms. Right? That's like trying to add x to x squared. That wouldn't work. I do want to move it over though, so plus e to the x and then minus 1.
Equality kind of? Or like what do they call
Quadratic?
Yeah.
Yes.
So what do we do with the x and the e? This is crazy.
This is crazy, you're right. This looks like 2x squared plus x minus 1 is what it kind of looks like. So I wonder if we could factor it like we would factor that. Two e to the x times e to the x, that would give me 2e to the 2x. 1 and 1 would get me 1. Now I just need to worry about the signs. So we're factoring, but like quadratic factoring when e to the x is involved. We have not done that before. Let's see. So I think I want whoever's attached to this 2 needs to be positive. That way we end up with a positive middle term there. Are you okay with that? Next we would just set each of those equal to 0. 2e to the x minus 1 equals 0. E to the x plus 1 equals 0. And so now we have 2 equations to solve. So e to the x equals 1/2. Then we would natural log both sides. Because natural logging both sides allows us to bring the x down front. And the natural log of e is 1. So there's one of our answers. Toby.
So for my fraction I got like 1 over 2 times like e to the x squared to the power of x. Like, is that how you like isolate the x more or less? Like whenever you make
So you're good to here. So I'm going to solve for e to the x. So I'm just going to add 1 and divide by 2. So move the 1 over and then divide it by 2. Then to undo the exponent, I natural log both sides. So there's one of my answers. Now let's go get the other answer. E to the x equals -1. Is there anything I could raise e2 to get -1?
No.
E to the x is always positive. So you could sit there and try to think about things, but e to the 0 is 1, e to the first is e, e to the -1 is 1 over e. So that I can't do anything with that. So it's only natural log of 1/2. Let's look at number 4. Was any other question on number 2? So that step in there where we're factoring with e to the 2x, that is new. That's a little bit different. Number 4. Find all values of x which satisfy that equation. You know what? I can throw some of these answers out right away. Because I can't take the log of a negative number. So it can't be -1. So I'm down to B and C and D. So I guess that's helpful, but I still got to work the problem. How can I condense the left-hand side? What would I do?
Divide them.
On number 4, I would divide them.
Oh, sorry.
It's okay. If you're looking at number 3, you would multiply them. But on number 4, we'll divide them. Oh, and this is good news. What do we do next? Yeah, I mean, the log of something equals log of something. I don't need the logs anymore. So multiply the x over. So negative 3 equals 3x. Right? Yes. X equals negative 1. And I'm not allowed to have negative 1. So what did I do wrong on this problem? Because those answer choices aren't matching up. Right? I can't use negative 1, so that's out. I think this one doesn't have a good answer choice. Because it should be not possible. Answer choice F, no solutions. X minus 3 over x equals 4. So x minus 3 equals 4x. Subtract the x, yeah, I think I'm right. A little bit of confirmation. Number 4 is no solution. So I'm glad we picked that one to do. 5 looks pretty straightforward. 6 looks okay. 7 looks okay. What I want to do is number 8, because that's more weird factoring stuff. Find the x-intercepts. What's that mean? How do I find x-intercepts? Set y equal to 0. So 0 equals e to the 2x minus 6 e to the x minus 7. So that's another of the kind of weird factoring problems. So I'm going to press pause. You see if you can factor that and kind of finish the problem. Okay, so there it is factored if you want to check and see how things are going. I'm about to press pause again and see if you can finish it. So set each one equal to 0 and see what happens. So we'll try number 9 next. So hopefully you're starting to get the hang of factoring these things that look weird, but they factor like all the normal things factor. Set them both equal to 0. And then maybe even only after a couple of them, you're starting to see, wait a minute, e to the x, that can't be negative. So I can throw that one out right now. And that natural log negative 4, that doesn't work. So I could have thrown that one out from the very beginning. Natural log both sides. And many of you are showing less and less steps, which is fine. Just means you're getting comfortable with the process. So x equals natural log 4. Not natural log of negative 4. So answer choice E. Alright, so we've done not quite half of them, but well, maybe so. 1, 2, 3, 4, 5. Not quite half. So today's assignment is just finish this worksheet. There's still 15 minutes left. Maybe you can finish it before you go and not have homework tonight.